All right, so we're in section 7.5 today. So the first thing that I want to talk about is, well, we know a little bit about what a square root is, maybe a little bit, but we want to talk about roots. So an example of a root would be something like the cubed root of 125. And what this means is a number multiplied by itself 3 times that gives 25. Sorry, 125. And if we experimented, we did some guess and check, we would see that 5 times 5 times 5 equals 125. So if we multiply 5 by itself 3 times, we get 125. Well, what's another way that we can write 5 times 5 times 5? That's 5 to the third equals 125. So the third root is kind of like the opposite of doing a third power. So we say the third root or the cube root of 125 is 5. And we could, if we looked at the fourth root of 16, if we experimented a little bit, did some guess and check, we would see that 16 is 2 times 2 times 2 times 2. This is the number that you multiply by itself 4 times that gives us 16. Sorry. 2 times 2 times 2 times 2 equals 16. And that's 2 to the fourth. So the fourth root of 16 is 2. Because I multiply 2 by itself 4 times to get 16. So I want to look really quickly at how we do this cube root, fourth root thing in our calculators. So let's look at the third root of 343. Now it might be a little more difficult to do guess and check on this one. So this is what number multiplied by itself 3 times is 343. So what we do in our calculator is, on most of our calculators, if you have a calculator similar to this, it's going to be the same. If you have a different kind of calculator, it might be a little bit different. And Ms. Lindgren and I can help you with that. So we want, for this problem, we want the third root. So what I'm going to do is say 3, because we want the third root. And then this up above, this up arrow, whoops, I want to delete that and delete that. Above the up arrow here, it says x and then kind of a square root. We want that symbol. So this 3 and an x, this means we're doing the third root. And then we're going to do 343. And we hit enter. And the calculator tells us that's 7. If you have a different kind of calculator, afterwards, Ms. Lindgren and I can show you this. And this means that 7 times 7 times 7 equals 343. Or 7 to the third equals 343. Let's look at one more. Let's do the fourth root of 256. So to do the fourth root, I'm going to say 4. And then I want to get this little x square root thing. So there's our fourth root. And I do 256. Enter. And I get 4. The fourth root of 256 is 4. 4 times 4 times 4 times 4 is 256. And this is the same as saying 4 to the fourth equals 256. Yes?
Do you have to label it 4 to the fourth power? Can you use
This would be what the fourth root of 256 is 4. But that's the same as saying 4 to the fourth is 256.
Right, but would both answers be accepted on the...
No, this is the correct answer for the fourth root of 256. This is just showing you the relationship that this means we're multiplying 4 by itself 4 times to get this number. All right, if you need help with your calculators, we can help with the calculators. And this is also a hint that you will need a calculator to do this stuff on the Chapter 7 test. All right, so why are we talking about finding roots? Well, we can kind of see the relationship here between a root and a power. We can write roots as exponents. So instead of saying the third root, we can write this as an exponent. Roots as exponents are fractions. So we can write roots as exponent fractions. So what we can say, for example, we have the third root of 125. We can write that as 125 to the 1/3 power. A root is an exponent that's a fraction. The fourth root of 16 we can write as 16 to the 1/4. The root is a fraction as an exponent. The third root of 343 we can write as 343 to the 1/3 power. And the fourth root of 256 we can write as 256 to the 1/4. Roots are fraction exponents. So that's going to be our rule for roots. I'm going to say roots are fraction exponents. And the way we'd write that in symbols is that a to the 1/n is the same as the nth root of a. When it's written this way, we call this exponential form. Because this is an exponent. And when it's written this way, we call it radical form. Radical is another name for a root. All right, so that's our first big idea for today, is that roots are the same as exponents that are fractions. We can also have exponents where the top number is not a 1. So if the numerator is not 1, then it is a power. So what we mean by that is if we had something like 8 to the 2/3 power, well, the 3 in the bottom is a root, and the 2 in the top is a power. So we can write this as the 3rd root of 8 squared. This tells us to take the 3rd root, and this tells us to raise it to the 2nd power. We can also write this as the 3rd root of 8 squared. The square, the power can go on the outside or the inside of the radical. These are the same. So the way we write this in symbols, so our rule is going to be a to the m over n. Well, this number in the bottom is a root. The number in the top is a power. So we can write that as the nth root of a to the m power. And that is the same as doing the nth root of a to the m power inside the radical. Both of these mean the same thing. When we have an exponent like this where the top number is not 1, we call this a rational exponent. So when we have a fraction, whatever's in the bottom is a root, whatever's in the top is a power. If the top number is just 1, then we just have a first power and we don't have to worry about it. All right, questions so far? Okay, let's look at some examples. And we'll look at doing these rational exponents in our calculator in just a second. So we have x to the 2/5. And the problem might say, write in radical form. So what it's asking us to do is change this exponent to a radical and a power. Well, whatever's in the bottom is our root. Whatever in the top is in the top is our power. So we can write that this equals the 5th root of x squared, or the 5th root of x squared. The square can go outside the radical or inside the radical. All right, let's look at another one that has a little more going on. 8a to the 2/3. All right, so now we have a product and a power. So we have a rule about a product to a power. That rule tells us we raise everything to whatever this power is. So this is going to be 8 to the 2/3 times a to the 2/3. And I want to write in radical form. So I'm going to leave this as 8 to the 2/3 for now. A to the 2/3, that's our power. And this is our root. So we get the third root of a squared. Or I could write it as 8 to the 2/3, the third root of 8, sorry, a squared. Well, let's figure out how we deal with this 8 to the 2/3. In our calculator, we can do this exponent, just like this. So in my calculator, I'm going to say 8. And then for my power, I'm going to use this little up arrow. And then I'm going to put parentheses, 2 divided by 3. This is 2 divided by 3. I hit enter. 8 to the 2/3 power is 4. So I could write this as 4 cube root of a squared, or 4 cube root of a squared. Either way will work. And this exponent on our calculator is the little up arrow. If you do an exponent in your calculator or something like this and it comes out to be a decimal, you can just leave it written as a decimal. All right, questions there? Okay, let's look at another example. This time we're going to go the other direction. Rewrite in exponential form. So we're going to start in radical form. And rewrite it in exponential form. Well, when we do that, this, whatever is the root, goes on the bottom. And whatever is the power goes on the top of our fraction. So this is going to be a to the 4/7 power. This is the root. This is the power. The root, the power. Questions there? Okay, let's look at one with a number. We'll practice with that calculator thing again. We have the 5th root of 32b cubed. We're taking the 5th root of everything. That goes in the bottom. So this is the 32 to the 1/5 and b cubed to the 1/5. I'm going to rewrite it as 32 to the 1/5. We'll do that in just a second. b to the third to the 1/5 power. This is the bottom. This is the top. So that's going to be a to the 3/5 power. And now we need to do 32 to the 1/5. So in my calculator, I'm going to do 32, raise it to the 1 divided by 5 power, and I get 2. 32 to the 1/5 power is 2. So my final answer would be 2a to the 3/5. Yes?
Can I ask why it changed from B to
Oh, no good reason. Maybe because this was an A up here. All right, another way we can look at this problem. We can split this into two roots here. We could think of this as the 5th root of 32 times the 5th root of b to the 3rd. So I can split that in two. So this is the 5th root of 32. This is the bottom. This is the top. So I get a to the 3/5. And then here in my calculator, I would do the 5th root of 32. So I can find the 5th root of 32 in a different way. To do that, I'm going to do 5. Then I'm going to get that little x square root thing. There's the 5th root, 32. And the calculator tells me that's 2. So two different ways we can think about this problem. Taking the 5th root is the same as doing the 1/5 power. The process of doing your calculator is a little different. All right, questions? Okay, our homework is a worksheet. We're going to do the odds and number 28. So let me pass that out, and then we'll answer questions on the homework, and then I'll pass the folders back.